Hello. In this video we're going to continue to talk about class hierarchies, specifically object construction. So in the past couple of videos we've been setting up this sample hierarchy to simulate a role-playing game. We have our player class, our wizard class, and our barbarian class. And to start this presentation we're going to add a couple new features to the wizard and barbarian. That is, wizards are going to belong to a circle, and that's going to be stored as a string. Barbarians are going to belong to a clan, and that's stored as a string as well. So since the circle only applies to the wizard, we're going to put that attribute or that field in the wizard class. The same thing goes with the clan. Because barbarians are going to belong to a clan, we are going to store that string in the barbarian class. If, for example, I wanted to have a field called name, which stored the name of the player, and we'll assume that wizards and barbarians both have names, we would include that in the player class. We always want to try and put fields and methods in the most generic class possible. This is a good design practice. Now, the next design specification that we're going to include is that wizards should have a constructor that takes an integer to represent the wizard's mana and a string to represent the wizard's circle. I recognize at this point we haven't talked about hit points, but for now we're going to assume that just gets set to some default value. And if we wrote that constructor, it would look something like this. Now, we really want to understand what's actually happening here. So because wizard is a subclass of player, we have to also construct that player component. And when Java constructs an object, it constructs it from the most general class to the most specific. So what's really happening here is that when an object is constructed, it's going to work its way up the hierarchy to the object class, which is the root of the Java hierarchy, and work its way back down. So what we don't see in the wizard constructor is a special call to the superclass constructor, which is this. This super here is a call to the player's default constructor. So assuming player has a default constructor, this is perfectly valid. And in fact, by default, Java includes that there. So every constructor you've written up to this point has this call right here. There's no need to actually include it. We just need to be aware that it is there. If the superclass happens to have a constructor that takes specified parameters, what we're going to do is rewrite that super call there, and we're going to include arguments inside those parentheses. And we're going to take a look at what that looks like shortly. But before we go on, take a second and write a constructor for the barbarian class that's going to take an integer and a string, the integer representing the barbarian's power and the string representing their clan. You should probably write something like this, but this is perfectly valid as well. What's really important to recognize here is that when we construct an object, we need to construct it from general to specific. I'm going to repeat this a number of times. And because of that, the first call has to be a call to the super constructor. So to call the superclass's constructor, we simply invoke it by saying super with parentheses. And like I said, super call must always be the first call. And if the super call is not written, then super with brackets is used by default. So let's pause for a second from our role-playing game and let's talk a little bit about constructor theory. Like I said, objects are constructed from general to specific. So given the example hierarchy and the line of code, which is right down here, Java would call the class B constructor and then move up to the root of the hierarchy and begin constructing each part from general to specific. So there's the constructor call. There's going to be some sort of super command that's going to call up to class A. There'll be some sort of super call that will call up to call up to object. We're going to construct object, then we're going to construct class A, then we're going to construct class B, and then we're going to return a reference to the newly created object. Since the superclass properties must be constructed before the subclass, the supercall must be the first line of code in the constructor. And just a little point here, remember constructors return references to the constructed object. We don't actually write a return type because by default they have to return a reference to that constructed object. If the supercall is not shown, the default is super. This call invokes a superclass constructor with no parameters. I know, I sound like a broken record. So here's a question for you. The wizard class is redesigned with the below constructor to account for the newly added fields. The constructor takes an integer to represent mana, an integer to represent HP, and a string to represent their circle. That is a group of wizards. Everybody knows that. The player class is given the constructor as outlined below. And the question is, would this compile and execute? So when you're looking at this code, these are the things you want to think about. You want to think about what calls to the superclass constructor exist, and then what actual constructors are there to be used. So if we look at the player class, there's no default constructor. Remember, when we write a custom constructor, that default constructor goes away. So that's the problem here. So since a constructor that takes one parameter is written in the player class, a default constructor no longer exists. Since there's no super call written, super with no parameters is used by default. Therefore, this won't run. So what's the fix? We actually add an argument to the super call, and then it works perfectly fine. So remember that. If you write a custom constructor, that default constructor disappears. Your super call in your subclass constructor must conform to whatever constructors exist in the superclass. So now let's look at this. Given the below definitions of the player class and the wizard class, would the code compile? Now just note here, I have set HP with a small h there and set HP with a capital H there. Let's assume that these match up. It's just a little typo on my part. So the impulse here might be to say yes, because, well, this is perfectly valid. I can invoke a method in the superclass and then set the HP. But the problem comes from this supercall again. In the wizard class, notice there's no supercall written explicitly, and in the player class, there's no default constructor anymore. So that presents a problem. Though using the built-in set method in the constructor is possible, there is a problem concerning the supercall. Since no supercall is written, there is an implied super in the wizard constructor. So that's what's implied. And this is an error because there's no constructor in the player class that conforms to that supercall. So one possible fix is to put a constructor in the player class to add another one that has no parameters, that does nothing. Then the question comes, is this the best solution? Well, though it fixes the problem, it's better to pass the information up the hierarchy using a proper supercall here. We really want to try and pass stuff up the hierarchy and assign the values in the class where they're defined. And like I said, this implementation is better in that it passes the fields within the player class up the hierarchy using an appropriate supercall. There it is. Now I've repeated myself a lot in this presentation because this really distills down to a couple essential ideas. So let's take a moment and summarize the last two videos to make sure we have those essential ideas. So let's talk about supercalls in terms of methods. So the command super.sum method will execute the first version of the method found higher from the class where it was invoked. So example 1, super.doThat executed in class C, that is down here, will execute the doThat method defined in class B. If I write super.doThat in class C, it's going to move one class up and look for doThat. Likewise, if I happen to write super.doThat in class B, regardless of what the object type is, it could be a class C object, it's going to move up and look for that doThat here. There can be a gap between classes that contain required methods. So this here, the second example, is perfectly valid. Super.doThat executed in class C is valid, and we'll start searching for doThat in class B. So if I invoke super.doThat in class C here, it's going to come here, look for it, not find it, and then work its way up to class A. The supercall only works on methods that are overridden. So this third example is invalid. Super.doThat executed in class C is invalid since there's no other version. It's not an overridden method. Therefore, we can't use the supercall. And finally, you cannot bypass a version of the method that are more immediate. Let me rephrase. Let me say that again. You cannot bypass versions of the method that are more immediate. that is, appear lower in the hierarchy. There must be a supercall made from the class. So our example here is students will often try and do this, and if you look at some old AP multiple choice question, you'll see super something. This is never valid. So if you wrote super.do that, execute in class C or anywhere, it's not going to work. So the intent often when we do super.do that is I kind of think that might bypass up to class A. If I was a class C object and I wanted to do that in class A, I would have to work my way into class B and then use the super command to invoke this version of do that. One of my students made the joke about there being an ultra.do that, but there isn't. So you have to kind of work your way up the hierarchy like that. So let's summarize super constructors. All objects must be constructed from general to specific. The super call in a constructor must be the first call. This is really important. If no super call is written, super with no parameters is set by default. And constructors that take parameters are called using super, and then we input the appropriate arguments. Do you understand it now? Super. So like always, if you have any questions, post them on my channel. Track me down. I'm happy to clarify this. It's really important that you sit down and play around with these ideas. I know this material can be a little dry, but getting a really good understanding of it now is going to make a whole bunch of really cool ideas or cool techniques available to you. Have a wonderful day.